Dear students, in this video, we are finding shortest path between given two vertices by Dijkstra's method. This is Dijkstra's algorithm. Now, here we have rules how to apply this Dijkstra's algorithm to find the shortest path between given two vertices in any directed or undirected graph. Here are the rules. Rule 1. Make sure there is no negative edges. Set distance to source vertex as 0 and set all other distances to infinity. It's very important. Source vertex is nothing but the starting vertex. Rule 2 is relax all vertices adjacent to the current vertex. This I will explain when we do the example question. Rule 3, that is, choose the closest vertex as next current vertex. Rule 4, repeat rule 2 and rule 3, repeat rule 2 and rule 3 until the Q or reach the destination. Now, see, consider this example. Use Dijkstra's algorithm to determine a shortest path from A to Z, vertex A to vertex Z in the weighted graph with minimum total weight. Now, we can apply this algorithm for directed or undirected graph. We have undirected graph here. This is the weighted graph. Why we say that this is weighted graph? Because here for each edge we have some weight. Maybe this 4 is some measurement, maybe kilometer or some other unit. Here how many vertices we have? 6 vertices, A, B, C, D, E and Z. Now we are going to find the shortest path from A to Z by this method. We have 4 rules. What is the first rule? Now you see here we need the shortest path from A. So this is our source vertex. A is our source vertex. So now for the source vertex we have to give the distance 0. See here, source set distance to source vertex as 0. Now we'll give for the source vertex A, the distance is 0. Okay. Then and set all other distances to infinity. Now write for all other vertices except A we have 5 vertices. For all other vertices we set infinity as a distance because we don't know what is the shortest path that we are going to find from next step. Now here first you assume for the source vertex distance is 0, for all other vertices distance is infinity. Now watch step 1. Now watch step 1. What is step 1? Now this is your source vertex A. Distance is 0. Now here this is the edge having the weight 4. Now this is the vertex B. This is the vertex B. To reach B from the source vertex, now how much the distance? That is 4. We have to write this here nearby this vertex. We have to write 4. We have to write inside the bracket A. Why we write A? Because we reach this vertex B from this source vertex A by this distance 4. That's why we are writing 4 and inside the bracket you write A. Now similarly you write for this vertex C that 2, because here for A distance is 0, here this edge is having 2, so 0 plus 2 2, so you write 2. This is the distance to reach C from A, so you write inside the bracket A. This is step 1. This is called relaxation. Now we are relaxing nearby this current vertex B and C, but here see we don't do anything, right? Infinity, 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 but we do change here B and C. What is the distance from which vertex we reach B? Here what is the distance from which vertex we reach C? Okay. Now step 2. You see step 2. Now here already we made circle or square for this source vertex. Now why we make square here or circle for this vertex C, because now you see here, this is the distance. 2 is the distance to reach C from A. Here, this is the minimum. We are going to fix, this is the minimum distance to reach this vertex from A. So now we cannot find minimum distance less than 2 to reach C. Yes, we cannot find. So you fix this value. So you make circle to distance to inside bracket, you write A. Okay. Now after fixing this, you have to relax the nearest vertices, which means now again see here we are going to change this B. Change the distance and vertices for B. Now you see we have 4 inside bracket A, but after fixing this minimum value, for C, now you have to relax the nearest vertices, which means B, D, E. So what we are doing, now you see here. Now what is the distance for A? Is 0. Here for C minimum 2. Now see for B, what I am writing, from A to C 2, distance is 2, from C to B distance is 1, so 2 plus 1 is 3. That's why I am writing here 3 distance. Inside the bracket I am writing where it comes from, that A, from A to C and then C to B. That's why I am writing A comma C. These are the vertices via we are reaching B. So now distance is 3. Similarly, now you see for D, what I am writing, 10. Distance is 10. Inside the bracket we are writing A comma C. Why? Because from A, we are starting from A, source vertex A to C, then C to D. So how much? So A to C 2. Here we already fixed it because here we made circle. So now 2, here 2 plus 8, 10. So this is 10 for D. Now for E, here I am writing AC, which means start from A, this distance 2, and passing through C, reaching E, this distance is 10. So total is 10 plus 2, 12. So now this is 12. So this is step 2. Now you see here, to reach the vertex B, the minimum distance is 3. In the previous step, the minimum distance is 4. But now what is the exact shortest path with minimum distances? That is 3. If we choose the minimum between 4 and 3, so this is the minimum. So 3 via A comma C is the minimum. So now I can make the circle here. That is in step 3. What I am doing, I am fixing this value. This is the shortest path to reach B, that is A, C, C. From A to C, C to B. This is the shortest path to reach B with minimum distance 3. That's why I am writing 3 inside bracket A comma C. I am making this circle. So now this is fixed minimum value for this vertex B to reach this vertex B by the shortest path. After fixing C, A, C, now we fixed B. Now again we have to write the minimum distances, calculate minimum distances for D and E, that is relaxation. So now you see here we got 10. Now you see here, after fixing the minimum value for B and C, now you see for D, vertex D, A, C, B, that is A to C 2, then from C to B 1, then here 5. So 2 plus 1 plus 5, 8. That is now the distance to reach the vertex D, that is 8. Why I am writing here ACB? Because this is the way, we are reaching the vertex D from the source vertex A, C, B, D. That's why ACB I am writing to reach D. Now we can write in the similar way for the vertex E also. Now A comma C, A to C 2, weight, and then C to E, weight 10. So total is 12. So now this is step 3. After fixing the minimum distance for this shortest path to the vertex B, now we are rewriting D and E. This is step 3. See now, After fixing the minimum values for the vertices A, B, C, now we are getting for D that minimum distance is 8 with A, C, B. So now we can make, see in step 4, now we can make circle for this D, because now this is the lowest or minimum distance to reach D from A, that is A, C, B. So A, C, B, D. Now this is the minimum distance to reach D. Now we have to fix. So I am making the circle now, because see here before 10. Now after fixing the vertices of A, B, C, I am getting 8. So this is the minimum. Between 10 and 8, this is the minimum. So now we fixed A, B, C, D. Now you see, similar way we have to calculate for E and Z. Now for E, what is for E? Now you see here, after fixing these 4 vertices with minimum distance, now you see A, C, B, D, which means A, C, then B, A, C, then B, then D, then reaching E, which means 10. Total is 10, because 2 plus 1, 3, 3 plus 5, 8, 8 plus 2, 10. So for E, 10. Now for Z, so 14 here. How we are getting 14 here? A, C, B, D. That is A, C, B, D, then here is it. So now 8 plus 6, 14. Now this is step 4. Now you see here, now we fixed the minimum for D to reach the vertex D, the shortest path with minimum distance 8. After fixing this, now you see here, for E I am getting 10. In the previous step I got 12. So now which is minimum? So 10 is minimum. So what I have to do in the next step? Make circle. Make circle. So this is the minimum. This is the minimum distance is fixed to the vertex E, to reach the vertex E via A, C, B, D. So A, C, B, D, E. So this is 10. So this is the minimum. So now that's why I make here circle. Now what we have to do? We have to calculate for Z. After, see, now we fix the minimum for all the vertices. That's why I put circle here. I marked circle, 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 here, circle, here, circle. So now we have to write the distance for Z. Now A, C, B, D, E, because here I got 8 for D, here I got 10 for E. So now here 8 plus 6, 14. Already we calculated here. So here 14. But now less than that we can get, because here 10. Now add this value, that is 3, 13. This is the value. This is the shortest path with minimum distance 13. So now A, C, B, D, E. Now this is step 5. What we have done in step 5? We have marked, we have fixed the vertex E, then we have calculated for Z. Now see in step 6, see for Z, this is our aim, A to Z. We have to find shortest path. So this is the shortest path. A, C, B, D, E, Z. Now what is the minimum distance of this shortest path? 13. So I can make the circle. That's why I make circle here in Z, which means we have completed the process and we found the shortest path also, because here previous value was 14. Now here with 13 we have completed the shortest path A, C, B, D, E. Now you see the algorithm terminates when Z is circled. So now that's what I did. So now here, therefore we find that a shortest path from A to Z is A, C, B, D, E, Z with the minimum weight 13. Now the thing is that you started from A, you stopped with the vertex Z. That is the shortest path needed from A to Z. Now whenever you fix the minimum weight for the particular vertex, you have to make circle, which means less than that you cannot find the minimum weight. So this is the minimum, so make circle. This is the minimum, so make circle. Then similarly you do it for Z also. Now which means process is over. So this is the shortest path for this given graph from A to Z.